Hey, good morning, everyone. It's a pleasure to be here. I'm happy to uh, get this chance to talk to all of you. This is, as he was introduced by Professor Rakesh. My name is Anoop. I'm a faculty member here at IIIT, and I work in computer vision, machine learning, and biometrics related problems. So today, I'm going to talk about uh, a subject that is overlapping between technical and slightly non-technical. The reason I'm trying to do this is to kind of present to you what happens when we try to take a technical problem that we usually think about into a real world situation where we want to implement a solution in real world. What happens? So I work in the area of biometrics, which is one of the subfields of machine learning. And when you take a biometric system and try to scale it to a large scale identity system, like a national scale, like in the case of our Aadhaar system, what would happen? And I would like to talk about different aspects of it. Some of it might be technical, some of it are non technical challenges. But as researchers, it's important that we keep other aspects in mind when we design technical solutions. Technical solutions by themselves usually do not see the light of the day because we think of technical solutions as, uh, you know, purely technical solutions. We do not connect it with real world many times. And because of that, the assumptions that we make while building a technical solution do not hold in real world. So what I would like to do through this presentation and discussion, and I would like to make it as interactive as possible, please feel free to stop me at any point and ask questions, would be to uh, throw some light on what kind of challenges beyond technical also can be there. So I'll talk about both technical and non-technical challenges. Okay. So please excuse me, I have slight allergic reaction, so I just keep sneezing in between. So please excuse me for that. I'll probably mute in between. Uh, so getting into the problem. So we all know biometric recognition. We use biometric recognition all the time. By the way, just a quick question. Can you also see my video, or is it just the slides that you see right now?
Sir, can see your video, sir.
Okay. So in case I just show something, like I can do that. So all of us use, for example, mobile phones, and most of the mobile phones have got either some kind of fingerprint sensor on it, or at least cameras on it, which can recognize you. Many of us use these biometric systems to lock and unlock your mobile phones. That is very commonly used by all of us. And then many of us also use biometrics in terms of attendance systems, in terms of access control, and several such applications. And if you nowadays go to the airport, most of the airports have started using face-based uh, unlocking systems where you can walk through the security gate using your face. Now it's called Digi Yatra. So you might have encountered biometrics in several uh, applications. Of course, almost all of us have got Aadhaar cards, which also took your fingerprints, face, and iris scans. So let's look at some of uh, the biometric systems. So we would like to first look at the process of scaling a biometric system from a simple authentication system like in the mobile phone all the way to deduplication, which is done in Aadhaar. We will look at some of the technical challenges of doing such things, some of the practical challenges beyond technical challenges, and how to go about designing a solution for this. And then from that high level solution, how do you come down to a biometric solution, which is the technical one that we usually want to design? And then how can we move forward in future directions from within that? That's the goal of the talk right now. So let's start with the mobile phone one. So what assumptions do we have to make if we want to build a uh, biometric system that is to unlock? So let's take your face-based unlock system. So before saying that we are going to use a face-based biometric system, we need to first decide what biometric to use. So what are the constraint that such a problem presents to us? So extremely important in the case of any system like a mobile unlock is user convenience. If the user is inconvenienced in the process of unlocking the mobile phone, they would much rather use a pin number or a pattern that you draw with your hand. That's more than enough for most people. So why would they go from a pin number to your biometric or face based unlock, for example, or fingerprint unlock? It's not because it is more secure. I'm not saying that it's not more secure, but most people do not want to switch. If you just say it's more secure if you use a fingerprint based unlock, it's not the reason. Usually people do it because it's far more convenient. You just put your finger there, it would unlock your mobile phone and they would start using it. So user convenience is extremely important in adoption of such a system. And there are other aspects in the case of such a system. It's uncontrolled capture setting. There is nobody controls how you put your finger or how you present your face to the system. The system happens in a completely uncontrolled or unmonitored setting. Okay. So sensing becomes a very critical factor. The sensors have to be very reliable without an operator interfering in the whole process or monitoring the process, overseeing the process. That doesn't happen here. And also it's extremely cost sensitive. You cannot put a sensor in a camera that is very costly. So the typical number that we talk about is something like $2 to $3 per sensor that you can put in a mobile phone. Anything more than that, it is unacceptable for a mobile phone system. And also it has to be extremely compact in size. It has to fit inside a mobile phone, and mobile phone is already cramped for space inside. Another aspect that you need to think about is the user is usually cooperative. So that means that when you put your finger on your mobile phone to unlock it, you want it to be unlocked. So the user usually get used to the system. They would present the finger in a way or present the face in a way that is appropriate for recognition over a period of time. The first time they may not get it right, but over a period of time, you get used to it. There's a user habituation happening there. So you hold your mobile phone the first time, it did not work. Second time, third time, over a period of time, you would get it right. And that is one advantage of systems like this, that user habituation is possible. Okay. So all these put together, you can decide upon what kind of solution you want to build. Once you understand the ground reality of a problem, then you can use that to decide, okay, now what modality can I use for this? So face becomes a very common solution because of this, because the accuracy is good enough. The way to present a face is natural. If you show your picture on the screen, you would naturally move your phone in such a way that your face is properly presented. So there is, you know, psychological factors that actually help in this process. And what kind of accuracy do you want? So there are a couple of numbers that I've put here, which we will get into quite a lot. The first one, what we call is FNMR, which is false non-match rate. That is, if you present your face to your mobile phone, how often does it not unlock? It does not match. So most common studies say that anything over 97-98% accuracy, people are ready to put up with error rates of that much. That is, when you try to unlock your phone, if you try it 100 times, 2 or 3 times, if it doesn't unlock, we are ready to represent or retry the attempt. That is a reasonable thing to do. So that is acceptable. But what about false accept rate? False accept rate says that somebody else try to unlock your phone. How often do they succeed? So if 100 people try, how many people would try in, succeed in breaking your uh, locking mechanism? That is, they can unlock your phone with their face. That it need not be very high accuracy. Usually people don't attempt. So one 3-4 times in 100 people try to, they succeed in unlocking it. It's usually okay because the attempts are usually less. Ideally we would like to have more, but that is minimum number that we need. And the cost, as I said, $2 or $3. The mode of working is what we call as verification. That is, you are doing a one-to-one match. So now we took a system, a problem of biometric mobile unlock. You looked at the different aspects or different constraints that the problem presents to you, and then we try to create a solution that is appropriate for that particular problem. Okay, so now we will try to quickly do the same for a couple of other problems and see how what happens. Let's take the same thing into a class attendance system. Some of you might have biometric class attendance systems. That is, in the class, you pass around this device, and every student just puts their finger on it, and their attendance is recorded. Okay, this thing can happen in also in offices. You will have a fingerprint sensor on the door where you go and put it when you enter the office, and it would record your attendance at that time. So this kind of a system, usually it works in this identification mode. That is, you don't also tell who the person is. You just put your finger and it's supposed to recognize you, which means your finger is compared against every other person in the class, and whichever is the best match, it identifies it's that particular person as you. So it's a 1 to n match that is happening. It's not a 1-to-1 match. So that is what is called identification as opposed to verification. So what other challenges this is present? The user interaction is variable because multiple people are using it. Different people present their finger or face in different ways. And sensor robustness is very critical because different people are handling it. It would become dirty more often. You need to have a sensor that is more robust. The quality also varies because different people might have different quality of fingerprints, and that would vary. Fast matching is required. You are trying to match 1 to, let's say, 100 students in a class, 1 to 100 matched, not 1-to-1 match as in the case of a mobile phone unlock. And the cost is also slightly more acceptable in the sense that you can, build a system that will cost about $100 because 7,000, 8,000 rupees is okay for a identification system, whereas in the case of mobile phone, you had to have it in $2 or $3. Okay, and it also has to be portable so that it can be taken around, but it doesn't have to be as compact as it has to go into a mobile phone. It can be like a box. Okay, and some level of user cooperation is also possible. So based on all this, people have come up with different choices, and the most common one that is used is fingerprint. Here, the false non-match rate, that is how often do you put your finger and don't get attendance, that also has to be reasonable. So one of the numbers is, these are rough numbers, you can say, is that if you are attending a class which, let's say, meets 25 times in a semester, if out of the 25 times, if one of the time you have to represent your fingerprint to get the attendance, that's okay. Well, but if you fail every time, then it's a problem. So 1 in 25 is like 4% or 5%. So something of the order of that is acceptable. Okay, and false acceptance rate is another issue. False acceptance rate means that you put your finger on the fingerprint and you are recognized as somebody else, and that's a big problem. So how often can that happen? And this is something that we need to get a little bit more into detail in the next problem. So right now I've put a rough number as 0.1. It actually has to be at least as low as 0.1. It has to be even better than that. Okay, we will get to details of that in a minute. Now, speed is also a matter. So in the case of speed, there are two aspects that we want to think about. The first is, in any machine learning system, as you have learned up till now, given a input, you do a feature extraction, and then this extracted feature is used to do the classification or matching. So there are two stages. You can think of it as two different stages: a feature extraction stage and a matching stage. And in the case of deep learning based solutions, this feature extraction is where all the heavy lifting happens. Remember, if you have a deep neural network, this is where the CNN works. So you have your image as input, you run it through a CNN, and the output is taken as a feature vector. So your CNN is being used as a feature extractor. Okay, excuse me. Give me a second, please. So your feature extractor is the heavy lifting part, and it should not take too much time. So a 0.2 second kind of thing is acceptable in this particular case. And The second aspect is matching. And in the case of matching here is we are not talking about one-to-one match. You're talking about one-to-n match. So that can also be something like zero point 0.2 to zero point 0.3 seconds. That is usually okay. We will get to details of this, how to do this in a later stage when we talk about large-scale identity systems. So this is a slightly more complex, slightly bigger system now, where you're trying to do one-to-n match for an attendance problem in a class or a factory or a office scenario. Okay. Now let's scale it up one more step. Like let's say a larger factory which is using biometrics for identification. Here, what happens is that instead of a class which has got something like 50 to 100 students, you have a factory which has got several thousands of employees. So let's say tens of thousands of employees. And in those conditions, the setting becomes even partially controlled. It's not inside a classroom, it could be outside. There is far more variability in the users. There is far more quality variation because in the factory the users might have more worn out fingerprints. Much faster matching is required because now you're going to match 1 to 10,000 instead of 1 to 50 or 100. And the constraints are slightly different and the cost could be slightly more, but now you need far more accurate matching because now every time I match my fingerprint against others, you're doing a 1 to 1000 match. So your false acceptance rate has to be much, much lower. As you can see, it could be something like 0.001% instead of 0.1%. So it's the requirements on the system becomes heavier or more stringent. The cost might be slightly more relaxed now because it might be possible to install a biometric system that is slightly more accurate, slightly more costly because you only need it for a couple of entry points in the factory. And at this point, it is possible, even though not often done, it's possible to use multiple biometric modalities, like you take your face and fingerprint and use it together. It's possible to do that, but still it's possible to use a single modality like a fingerprint in this case. Okay. So now we scale it up to, let's say, a nation scale biometric system. So in most biometric system that we discussed up till now, the probe, which means the number of times a system is used, is something like hundreds to thousand times a day. And the gallery, which is the number of people in the system, is somewhere between 100 to 10,000 as we discussed up till now. Okay, that's a scale that we talked about up till now. But when we talk about larger biometric systems, we can see things like border crossings. So if you have a border crossing in a country, and how many people pass through the system, typically you have not hundreds or thousands but tens of thousands of people passing through an airport, for example, in a day. And every person who passed through the airport, if you want to use a biometric system to identify them, you would be matching them against a much larger database, lakhs of people in the database that you want to. So many times such a system is used for excuse me for uh, like a watch list. So I want to know whether a particular person who is leaving the country or returning to coming into a country is part of a watch list. So the watch list can be quite large, and one-to-one matching can be quite big. There was a system deployed in Disney, for example, Disney World, which uh, identifies the person who is entering the Disney World. Is it the same person who has actually bought the ticket or not? So that they don't buy a ticket and then transfer it to multiple people one after the other. So there are such systems that have been employed. Okay, and in the case of Disney kind of systems, is usually one-to-one matching, but it is much larger in number. Border crossing also can be both one-to-one and one-to-one. Like if you have present your passport and your fingerprint, then it becomes a one-to-one matching. But if you don't present your passport, like in a watch list scenario, it could be one-to-one matching. So the scale and the complexity of the system is now increasing. Now, let's say we go from there to a nation scale identity system, like a public distribution system, a ration card system, or criminal databases, and so on. Here, you will get hundreds of thousands of people using it in a day. And the galleries are usually of the order of tens of millions in most of the countries. Okay. So this is what largest biometric systems used to be till our own Aadhaar came along. Okay, and Aadhaar really took it to another order of magnitude larger. In the case of Aadhaar, the number of inputs that are coming in are of the order of millions in a day, and the gallery size is of the order of 1.5 billion. Okay, we'll look at some of the exact numbers later on. So it's really, really large in terms of the throughput that is required. So what happens when you try to take a system that is usually deployed in the order of, you know, hundreds or thousands of tens of thousands of people to a system that has got millions or even a billion size? What are the challenges that happens? Many times we think, okay, you need, higher throughput, so maybe we need more machines to match. You need higher accuracy, so you might have to develop some algorithms that is even more accurate. You do all that, but things doesn't work. So we will see why it doesn't work in the upcoming slides. So I would like to stop here and see if any questions up till here. Excuse me. Yeah. Anybody has got any comments or questions until this point? Are we okay? Are we going at the right speed? Do we need to speed up, or am I going too slow?
It's okay, sir.
Okay, so let's move forward. If you have any questions, please feel free to ask. Okay. Is there a chat window here you could ask
Yes,
questions? Okay. Yeah, I think there's a chat window here. So in case you have any questions, you can also type it in the chat, or you could unmute and ask. Either way is fine.
sir. There is a one question.
Yeah. So this question from Moti Gupta: for improving FAR, do the sensor quality matter in considerable manner in ML algorithms, or the ML algorithms matter much more? So false acceptance rate is when you present uh, your finger and you are matched as somebody else. Or in other words, if you are trying to use it for mobile phone, somebody else trying to put their finger and it matches with yours. Okay. So now there are these two kinds of errors we talked about: false match rate and false non-match rate. False match rate is also called false acceptance rate, FAR. That is when somebody else's biometric is matched as yours. False non-matches when your biometric is not matched with your own biometric. These are the two kinds of errors you can make. And you would see, as we move forward, we would see that there's a trade-off between these two kind of errors. So it's possible for you to reduce your false acceptance rate significantly, but your false non-match rate at that point will go up. If you try to reduce the false non-match rate, your false acceptance rate will go up. So this is like a trade-off between these two kind of errors. And where you can play in between these two, that's where the quality of the biometric works. So if you have a good quality biometric, it would be the trade-off would be much lower. You can play around at a lower level. If your quality is poor, then the trade-off would be at a higher level. That is, when you try to reduce one, the other one would go much higher up. So it is a combination of the two. So yes, quality is extremely important. And like in any machine learning system, we keep saying this phrase that garbage in, garbage out. So if your data is bad, you can't do anything with it. The performance levels would significantly be lower. So that would come up as we discuss further. How do we ensure quality? But of course, given poor quality data, it's possible that you can have uh, systems that would do better. So modern machine learning systems like deep learning algorithms allow to some extent mitigate some of the quality issues. But at the end of it, if you don't have good quality data, you would never be able to do a good job in it. Yeah, that's extremely important. Uh, so there's a question from Shravanti. She asks, how can we improve the security of biometric data? Okay, so that's a whole different topic. I do research in privacy and security in biometric systems, and that's something that is close to my heart. I unfortunately don't have enough time today uh, to go over that aspect. That's a whole different discussion. I would try to touch upon it towards the end about security. Okay. So thanks, Ravanti, for the question. But it's extremely important issue. It's several ways in which you can deal with it. So we will touch upon that as we move forward. But it's a whole discussion on it in itself. Okay, so let's move forward. We have lots to cover. So if you look at the standard biometric systems that exist in the around the world, the large scale biometric systems that exist in the world, how big were those systems and what kind of biometrics were used for that purpose? You can see, there's several countries like South Africa, Malaysia, European Union, and so on, which had couple of tens of millions, like 20 million, 30 million kind of number of people enrolled in the system. Okay. And most of them used face and fingerprint as the primary biometric modalities for that. In the case of Mexico, which was, Mexico is a much larger country in terms of the number of people. They had of the order of 100 million people in it, and they use face, fingerprint, and also the iris for their system. Andhra Pradesh actually tried to introduce a public distribution system based on iris-based recognition and also face. Uh, this was some few years back before Andhra Pradesh split into Telangana and so on. This system was created and it went through all kinds of problems. I was part of some of the meetings which tries to mitigate the errors, but then once Aadhaar came along, it kind of the issue went away because people started using Aadhaar as the backend. US Visit was the largest system that was available until Aadhaar came along, and that had about 120 million people in it. These are all the people who were visiting US, and employees of federal government and state governments and so on. They were all enrolled in the system. So it's a huge system, and it used both fingerprint and face recognition in that. They did not use iris. And when Aadhaar or Unique ID started, we had a discussion on what kind of biometric system should we use. And considering the scale of the system, our decision was to use face, fingerprint, and iris. All 10 fingers, two iris, and the face. All together was the decision. And primarily, this is because of two reasons. One is you need accuracy. As you will soon see, the accuracy requirement would be very, very high. Second is when we're talking about a system that covers all of India, and when you say that you cannot deny an Aadhaar to anybody, this becomes another important point as we move along. It's possible that some people don't have fingerprints. Okay, they might have their fingers chopped off, or because of some uh, genetic or not genetic, the deformities as during birth, it is possible that they don't have fully grown fingers. So if you have any such issue with your biometric, then you will not be able to provide your fingerprints, and you cannot deny the person Aadhaar just because they don't have fingers. Recently, we had a case in Kerala where uh, a lady was born with not fully formed fingers, and she was not given an Aadhaar card, and then she had to go through all kinds of uh, issues. That even though the Aadhaar system is set up to handle that, the authorities did not somehow allow it, and then she had to approach the court and some higher authorities actually in Aadhaar, and they said, you have to give this, and then they use the face and iris to do that. That technically it is possible, but there is also the human factor in there. So it's important for coverage purposes as well as accuracy purposes to have multiple modalities, and that's the reason why we went with fingerprint, iris, and face, all three together. Okay, so that's where the Aadhaar system started. So it's an order of magnitude larger than anything that was attempted in the past. The largest was 120 million, and now we are talking about 1.2 billion. Actually, it has grown beyond that. It is closer to 1.4 billion now, and it is designed to go even higher, up to 2 billion and so on. Okay. So the first question. So I was kind of fortunate to be part of this group which started the initial discussions about Aadhaar in 2008, 2009, when Nandan Nilekani was trying to decide how to go about this one. They called a bunch of people who worked in the area, and since there were not many people in India who were working on biometrics at that time, so I happened to be part of the initial brainstorming group. And the question that was asked is at that point is it feasible? Is it possible to do a national level identification using biometrics? Is it possible to tell apart at that time 1.2 billion people with biometrics as the base? Okay, so how do we know this? What data do we have? You cannot just go back and say, oh, it is possible, or oh, it's not possible. There were people who said this would never happen because accuracies and speed required are beyond what is capable. So what we did is we did, as like in any research we do literature survey, we looked at the existing systems or studies that existed. So thankfully, in 2003 2004 time period, NIST, the National Institute of Standards and Technology in US, they conducted this fingerprint vendor technology evaluation, FPVTE evaluation. And what they found is that the best systems in the world at that point had something like at a single fingerprint level, you can achieve 99.4% true acceptance rate at a 0.01% false acceptance rate, and also 99.9% true acceptance rate if you are willing to do a 1% false acceptance rate. As I said before, this is a trade-off between these two kind of errors. Okay, and if you use two fingers, the accuracy would jump up to 99.5% with a false acceptance rate of 0.1% on a database of 6 million people. So this is another study that was there. Two independent studies. Of course, the numbers are not exactly matching because they are not on the same data set. Okay. Then there was this large scale test which was run, and there were several one-to-one, set-to-set comparisons of fingerprint comparisons were done, and they this were all done as part of this study, and that's where these numbers came from. The 99.9% and so on comes from this large scale testing, where they collected all the 10 fingers, 1 to 10 fingerprint images, and then tried to compare all 10 images, and you would get very very high accuracies for those. And some of these systems, these are the companies that kind of topped the system. NEC was one of them, Sagan was one of them, or L1 as they used to be called, and then Cogent was another system from US. So these systems, NEC was an American company, but they are no, Japanese company which had collaboration with IBM and so on. So there was a Japanese company, a French company, and an American company which kind of topped the accuracies in the system. And what we figured is that if you take the best systems in the world, if we have access to the best systems in the world, we should be able to do India scale, that is 1.2 billion scale deduplication with all 10 fingers and iris. If you take together, then that should be good enough. And of course, face was captured just for human verification as well. So we had decided that if you do all 10 fingers and the face and the iris, we should be able to achieve sufficient accuracy for India level systems. So that is the first ballpark number. So think about how you, if you were in charge of the system to decide how would you go about designing this. So the first is, yes, there exist some systems in the world whose accuracy seems to be comparable to what we want. But now the question is, all this works nice in US. What if we take such a system, like the question that you asked, what about quality of the data? What if I take that system and take it to the villages in India, and if you try to deploy it there, will it work at the same accuracy level? Will the quality of fingerprints be the same? Will the people who work in the fields, in the farms, will their fingerprint, because they would be worn out, they'll have cuts and bruises and so on, will it still work? How do we know? So how can we start a national identity system before even knowing this one? Okay, so that becomes an issue. So what do we do? What we did is we did a pilot study, a proof of concept study. So this was in the early months of 2010, when we created a system which looks very similar to the current Aadhaar enrollment system, which captures 10 fingers, 2 iris, and the face. And we ran a proof of concept, a POC study, in the villages of rural Andhra Pradesh, Karnataka, and Bihar. And we had to answer a few questions like, can the iris be used How about blind people, people with cataract and so on? Will we be able to use it? How well the fingerprints of rural people can be captured? Can children above 5 years of age be enrolled or deduplicated? And how do we capture all this 10 fingers, two iris, and one face, and also do some quality check of the data while it is being captured? What kind of software should be there? There's several such questions that we had to answer, and so the what kind of sensors to use, uh, are they robust enough, how do we transport it? Several minor things had to be done, and we did that, and we did about capture about 40,000 people. So it was a reasonably large scale study, and a white paper was published based on it. Uh, I was not part of the white paper thing. I was only part of the initial discussions. But the white paper was published, which talks about the role of biometric technology in Aadhaar enrollment. And it concluded at the end that based on these studies, it is possible, it looks like it is possible to scale up such a system to India level. So again, I just want you to imagine, like, even though it is a technical problem for us, you need to think about the larger scale issues of the quality and the feasibility, the process of it, how to capture uh, all that, and do some initial studies so that based on it we can take a call on how to go about creating such a system. Okay, so uh, that's what I would like to appreciate. And right now, if you look at the current state, is this is as of yesterday, Aadhaar status. If you look at it, it has already had about 1.38 over 1.38 billion Aadhars which are generated, which means the number of entries could be more than that. If somebody has tried out multiple times to enroll, that would be more than this. So these are the number of unique Aadhars that have been generated. And in the peak case, when the Aadhaar enrollment was at its peak, now it is reduced because most of the people are already enrolled. Now it is at like a steady state. Uh, at the peak, we had something like 600 trillion matches a day. It's a huge challenge to do this level of matching. And over 10 petabytes of raw data is present in the system, and you have over 2 billion authentications happening every month using this particular system. Excuse me. Okay, so it's a very, very large scale system. This is, by the way, on the Aadhaar dashboard. You can go and look at it live at any day, anytime. You can see the current statistics up there. Okay, it's openly available. And it has created a lot of impact beyond it. Like once the system was in place, this has been used as backbone for primarily for welfare and subsidies. But one of the side effect is that almost everybody had a bank account by then. From there, all these other services that have been built in India right now, the UPI was the second layer of digital infrastructure that was built, where you could, all of us use now UPI for payment using your Google Pay or Paytm and so on. And several other systems are now planned to be built on top of this Aadhaar. So Aadhaar kind of became a backbone of several other systems that was going to be built on top of it. So UPI, UHI is coming up, Universal Health Interface, and then several other things are planned in that pipeline. Okay, some of the interesting side effect that happened is this lost and found children. There were cases of a lot of children being kidnapped, and they later on, when police raid some place and finds these children, unfortunately what happens is that by the time the children are usually kidnapped at very young age, they don't even remember their parents or their hometown or any of that sort. So you have no idea how to return these children back to their parents. So the parents have lost their children. They have been found somewhere else in the country, but nobody knows whose children is what, okay, or where these children came from. So one of the things that was done is, there was a push towards enrolling infants as soon as they are born into the Aadhaar system. And later on, if one thing that is done is, if some child is found somewhere in India, they run a match of the fingerprints of the child against the Aadhaar database, and there is a sub database for lost and found children, and it is matched against that. And if a match happens, then you know who the parent is. So it's a lot of, actually thousands of children have been reunited with their parents because of this. It's a side benefit that we have received. It's a very fulfilling thing when you get that kind of benefits out of it. Okay, and of course the other impact that has happened is that the acceptability of biometric systems has gone up. the cost of these devices have come down. The fingerprint and iris devices were several lakhs of rupees uh, before Aadhaar started. But when Aadhaar started, we started ordering numbers in much higher numbers, that the cost really came down to few tens of thousands at this time. So, lot of other benefits has happened on top of such a system. So it's another interesting thing that, when you think about design of systems, digital systems in India, how to build a system in such a way that other systems can be built upon it. This is another system design principle that you learn. If you learn, let's say, operating system, this is one of the principles that has been there a long time. For example, when Unix was designed, uh, one of the important thing that the people who designed Unix did was that they did every system to be very simple and single focused. So if you talk about file system, it only deals with the file system, how to store files, how to serve files. There is another subsystem that deals with networks, which only deals with how to communicate over networks and nothing else. There's another system that deals with the process scheduling on the processor, which only works about that. So, and because these systems are single focused and modular, you could build larger systems on top of it. You could make the system distributed, scale to larger multi-processor systems, and so on and so forth. One of the design wins of Unix is that the philosophy of making things simple and single focused. If you look at Aadhaar system, you would see similar things. You would see that it is only doing one thing. It verifies identity, and that's it, nothing else. It does not do anything more than that. And because the system was created to be simple and single focused, you could actually use it in several other systems as a part of it. So as a person who thinks about solutions in future, I would urge you to think about this philosophy of trying to do one thing and do one thing well. And that really helps in uh, scaling up your system and making it robust, and also making it possible to use the system as part of larger other systems. Okay, so it's a very, very interesting learning that comes out of such a system building. So that's the story that I have to give. Now I'll focus on some of the challenges. I'll quickly run through some of the challenges, and then we'll get into the technical challenges part. Any questions up till here? Okay, I don't see any questions in here. So let's move on. Let's see uh, some of the challenges right now. Okay, so definitely there are technical challenges in it. That is what we are interested in as technical people, as how to use our knowledge of machine learning and pattern recognition, image processing, and so on to do this. But my initial point is that technical challenges is only one of the challenges. We will talk about this in detail, but many times what we miss out as technical people, we are all trained as researchers who want to solve technical problems as engineers, and we tend to ignore other challenges. So I just want to quickly run through some of the non-technical challenges to give you an idea as to how complex the other challenges are. Okay, so what about social challenges? you know uh, if you try to scale a system to the whole country, now you're saying that every single person should get an Aadhaar system, an Aadhaar number. How do we ensure that everybody will use it or everybody can use it? Okay, so there are issues like, if you use face, and in some cases maybe the face is covered partly, and in some of the villages or in some of the cultures it is inappropriate to show the whole face. Okay, now how do we deal with such a system? Can we say that no, you can not do that? In some cases it might be possible. So in the case of a national ID system, maybe it can say that yes, for the purpose of enrollment you have to show your face. So you might create a separate room where they can take off the face cover and capture the face, but you should still be able to identify, or later on for authentication we may not be able to use that. So in that case you should be able to authenticate with the fingerprint. In the case of fingerprints, In the case of several vocations, it is possible that your fingerprints become dirty, bruised, cut, and so on, and it should still work. And there are several cases in which there are social stigmas where people don't interact. Unfortunately, in a country like ours, still there are uh, taboos on people interacting with each other. And this picture on the right hand side here is a case of a bunch of children who are, kind of did a protest begging to give them Aadhaar numbers, where they were denied by the village people who are the village pradhan and so on. And because of social ostracization, they were not given Aadhaar. I mean, they were not given services in general, and Aadhaar was one of them. So that's one thing that happens. Uh, Another interesting thing that we realized when we started out was that it's very common for us to ask, what is your name, what is your address, what is your date of birth. Uh, Not all over India this will work. It may not be so obvious to us initially, but many people don't have names. Names in the sense that names that we know. We all have a first name and a last name, okay, at least. And several of us have got, three names, four names, six names uh, in our whole complete name. But in some of the villages or many places in India, it's possible that some people don't are not given such formal names. You born in a village, you are called, one of the most common names is Chotu. You're born, you're called Chotu, and you're always called Chotu. As you grow up, you become old, you're still Chotu. Now there will be 100 Chotus in one district. How do we understand who is who? So name, as we expect and understand it, may not be exist. It's more like a nickname that they have. They don't have a formal name. Address, we think all of us have got addresses. What about people who don't have addresses? What about people who don't have homes? Can we say no, you need to have a home to have a Aadhaar number? That's not fair. Even worse, there are significant number of people who in India, not only that they don't have an address, they don't have the concept of an address. Okay, it's not that they don't have a house. They say address does not mean anything to them. These are nomadic people. What does address mean? You belong to, or you stay in a fixed location in India, in a house. Okay, whether it belongs to you or not is not a problem. At least you're rented, you're staying in a house, you have an address. But what if you don't stay in one place? Every day you sleep in a different place. What is address to you? you know they don't have conceptually the meaning of an address. It's Address is just a uh, alien concept to them, because you don't belong to a location, a latitude, longitude in the world. The whole world is where you wander around. So, and such people are in millions in India. So you think that's a small exception, but when you scale a system to national level, exceptions become important categories. You might think it is very, very less, but that very less number becomes millions. Okay, how many people won't have all 10 fingers on their hand? Millions of people in India. How many people cannot present their eyes because of blindness? Millions of people in India. How many people don't have first name and last name? Millions in India. How many people don't have the concept of address? Again, in millions. This is the problem when you think about scaling a system to encompass a larger community and larger group. Exceptions that you think initially would become significant groups, and you need to deal with that. You cannot just ignore that at this point. Date of birth, a lot of people who don't know their date of birth, they don't know when they were born. So what Aadhaar said is that when you enroll, if you know your date of birth, give it. Otherwise, give us a year of birth. If you don't know that, give us an approximate year of birth. Okay, so there are some biometric solutions you can build on top of it. We'll talk about that. Financial issues. How much cost can it have so that it will become practical? What is the cost of the enrollment center? The iris scanner, the slab scanner, the laptop. How do we make it cheaper? Who bears the cost? If you while enrolling it, it'll incur some cost. So how do we incentivize people to participate? If you say that for you to enroll you need to pay some money, then many of them won't participate. So how do we incentivize the users to join? Even if you say it's free, people may not participate. So how do we incentivize that? And what about the running expenses, the upgrades, the personals, the power required, the R&D required? Where does all this money come from? Okay, and it has to be created into a system that is reasonably uh, clear what the financial benefits are. And that is another aspect that when you try to build a system. Political issues. This is one of the interesting sidestep, what we call as stepping on others' toes. Uh, it's a big issue in something like this. When a particular branch of government tries to implement a national level ID system, there will be other branches of the government will say, no, 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 you cannot do it because this belongs under our jurisdiction. Okay, you are not allowed to give a national ID card because you are not, your department who is trying to install to implement this is not in charge of deciding who is an Indian and who is not. That belongs to some other department. So now, how do we go forward? In fact, an interesting point is that Aadhaar system is not the first national ID system tried in India. There were several other attempts at creating national ID systems in India which failed. And if I uh, remember right, it is something like 14th or 15th attempt at creating a national ID system. Over several decades, several attempts has been made, and all of them failed at various stages. So it is actually a miracle that finally we were able to create a system like Aadhaar, which is all over India and now accepted as single identification system. Okay, in operational issues. By the way, political issues also involves all kinds of uh, objections against Aadhaar. Uh, some of them are valid, some of them are not valid. So it's important to be able to listen to valid criticism, and to be able to adapt the system to take care of the concerns of people. If you don't do that, then the system does not really benefit the people, and then the whole thing becomes pointless. Operational issues like creating awareness of the system. How do we uh, get people to know that such a system exists and what are the benefits and so on. How to take the enrollment centers closer to users rather than asking the users to come to the centers. How to deal with operator errors. If operators make some mistakes, what to do. If the operators are uh, unscrupulous, if they start misusing the system, how do we detect that? How to transfer the data from the enrollment stations to the so initial enrollments when they were happening in the villages, how do we transfer the captured data to the central data repository of Aadhaar? The internet connectivity was very poor in 2010, especially for this kind of transfer. So the solution that was created is that every person operator would capture the data for a day. They would plug in a hard disk on which all the data would be copied. The hard disk would be shipped to Bangalore or Delhi, and then the data would be physically copied onto the server, and from there it actually gets deduplicated, and then the the return also, the UID delivery. How do we deliver the Aadhaar numbers back to the user? And thankfully, there existed a system of transferring these things back to all over the India, the Indian postal system. So Indian postal system came along and said that we will do it. So you just give us the number, the postal system will actually create. They will also do the printing, uh, putting it in the envelope and mailing it all the way to the user was taken care by the India postal system. So that tie-up was very important in the success of it. How to deal with system failures, like what happens if the one of the servers crash, what to do with fraud in the system, how to deal with vendor locking. That is, you get the system from a couple of companies, and what if those companies later go bankrupt, or some of the companies come from outside India? What if that country says that no more services to your country because of some political reasons? And now if the whole Aadhaar system fails. So many such challenges that we don't usually think about when we think about a technical solution. Privacy, as some of you mentioned, is a very, very important issue. uh, you cannot do forceful verification, and if what if people use Aadhaar system for as a criminal database? Like, what if the police start using Aadhaar database as your to identify criminals? The problem is not that we don't worry too much about criminals. The problem is we get uncomfortable if our fingerprints are in the system, and if some criminal is caught somewhere and accidentally their fingerprint matches with mine, which is a possibility. Now I'll be pulled up saying that your fingerprint was found in this crime scene, that was matched against the database, and somebody's fingerprint popped up, because usually from crime scenes the quality of fingerprints would be poor. it accidentally matched with mine. Now I'll be under suspicion until I can prove that I was not there in that particular time at that particular place. I'll be in trouble. So if that is the case, then I would not want to enroll in Aadhaar system, because if my fingerprints are available for the police all the time to match, and accidental matches can happen and they do happen, how do we deal with this? So one of the initial important decision that was made was that this system cannot be used for criminal matching. Not because we don't want to catch criminals, it is because the side effects of using that is tremendous. It is extremely uh, damaging if you start using this as a criminal fingerprint database. So function creep is something like we talk about this, that you start with one functionality in mind and then slowly people start adding functionality to it, and it finally ends up being something far beyond what it should be. Like tracking of users is one issue. Revealing more than the identity is an issue. Like what if somebody wants to verify my identity, but it also learns many other aspects about me by doing this unique identification. So privacy issue becomes a very important, and some of the initial design decisions about Aadhaar actually stopped some of these function creeps. So once again, the fundamental philosophy of doing one thing and doing it well was repeatedly enforced in the implementation of Aadhaar, so that the police and other systems cannot use Aadhaar system for their one-to-one match. So that becomes a very important aspect of designing such a system. Security, as some of you mentioned, is extremely important. How is this system secured? One of the things that is extremely important is that this biometric data that goes out from you, it goes into a system called the CIDR, the Central ID Repository, which is inside a data center, uh, two different data centers right now in Bangalore and Delhi. And these are extremely secure installations. You cannot get into those systems. They are, disconnected from the internet. You cannot hack into those systems. They have very, very strict uh, data security policies and systems and physical security that has been created there, that uh, even though I worked with Aadhaar all this time, I have never been able to enter into that part of the building, or inside that place. I've seen it before Aadhaar started, but after that, I have not been able to enter because I don't need to go in there. Okay, so not allowed. Only people who really have to be there are allowed inside with explicit clearances. You cannot take any pen drives or any other even cell phone inside there, so that the data can leak out. No internet connectivity, Wi-Fi, nothing is allowed inside. It's a very, very secure. So that those kind of security is required. Now you might have heard several of Aadhaar leaks and stuff like that. Recently, there was some story of large number of Aadhaar data being leaked. One thing that you cannot prevent is information leaked from other places. Like this, none of these Aadhaar leaks actually happen from Aadhaar. It is that somebody else decides that, oh, I will just collect Aadhaar number or photographs from people and keep it in my database. This is outside Aadhaar, and that thing get breached, because if you don't put normal security measures, then your database can be breached. So, there have been several cases of breaches of other databases, and those databases might have stored some information of the users, like name and Aadhaar number and so on, which then can be compromised. So at least from the design and the history, I know that from the Aadhaar system itself, security breaches has not happened, but outside it's possible that such breaches can happen. Okay. And of course, adoption of mobilizing users, adoption by different agencies. There are a lot of effort done in making sure that other agencies cooperate with Aadhaar system and not fight against it, because they were taken into confidence at the beginning itself, and they were involved in the process of designing of the system so that it becomes useful to them and not fight against what their interests are. So that's very important when you think about decisions. So as you can see, like all the story that I said, the technical part still hasn't come, and still there are so many issues. So your technical design has to cater to all these other constraints. We usually don't think about them when we think technical system design. And that's the story that or the message that I primarily want to pass to you today, that if you want to solve a technical problem, solve a problem which actually exists in the world. And in India, we don't have any dearth of real world problems. We have large number of real world problems. It is important for us, researchers and technical solution creators, to be able to understand the reality of the ground and use those constraints in deciding the problem that we want to work on and designing the solution that we want to create based on it. Okay, so that's basically the high level story. And now we can move on to the technical challenges. This is where, of course, what we work on. So we have another 20 minutes or so to discuss the technical challenges. We have actually spent more time on non-technical challenges than technical challenges, but uh, the reason that was partly deliberate. I wanted to spend more time on convincing you that there are several other challenges that we want uh, to address, so that the solutions that we create would be actually useful. Okay, so before we move on to the technical part, any questions here? Okay, let's move along. If you don't have any questions at this time, we will. So, what kind of technical challenge exists when you try to create a large scale identity system? Okay. Uh, of course, you need high accuracy. We will talk about that. You also need high throughput and response time. That also we'll talk about. So those are two primary challenges. Extremely accurate systems, and because it is large scale, you need yeah. Some question, I believe. Hello. Is there a question here? No. Okay. So there's some sound which came along. So those two we will get to, but there are several others which we don't have again time to discuss everything. So I will skip these others. One of them is data persistence. That is, whatever data that we collect, we need to make sure that the data is both uncorrupted and made available all the time. In spite of facts like the computers can crash, the hard disk can go bad. You can have even when you design a system of this sort, you also need to worry about what if there is an earthquake and the whole building comes crashing down. Can other data be lost? You cannot, because this is something that has been collected over a decade now, and you cannot redo that effort. So that's part of the reason why currently the data center is now split between some in somewhere near Delhi and somewhere near Bangalore now. It's two different places, and even if one of the places completely burns down or something happens, still a complete copy is available at a different place. So these kind of care has to be taken in terms of the data persistence, the acquisition of data, how to ensure quality, how to ensure security. There's something called presentation attack, and detection of those presentation attack detection or PAD is interesting technical problem. User data privacy is an important problem. Some of these we do work on, so we try to touch upon it. And reliability and availability, because if you have a system like this, it has to be available. If it's not available all the time, then some of the people will not get their pension or ration and stuff like that. So it's extremely important that users are not inconvenienced due to inavailability of the system. So how to make sure that such systems are highly available is another important issue. But we will primarily focus on these two aspects of throughput and response time. Sorry, accuracy and throughput. So when we measure accuracy in a system, as I said, there are two kinds of errors that we talk about. The first type on the left hand side, just imagine the colors represent identity. So if I match two, let's say two biometric, let's take fingerprint as an example. I take two fingerprints from the same person. These are called genuine pairs. It's supposed to genuinely match. they are genuine presentations, and which means they are supposed to match. So blue to blue, orange to orange, green to green, and so on. These are genuine pairs, and they are supposed to match. If they match, that is good. That is called a true acceptance. If they don't match, this is called a false match. So false non-match. It's supposed to match, it does not match. It falsely does not match and is called a false non-match. So the rate at which the system does not match genuine pairs is called false non-match rate. Okay. Uh, so FNMR is the number corresponding to that. It's a false non-match rate, which tells you how often a genuine pair is discarded as not a match. The second set of matches are called imposter pairs, that is, two fingerprints from two different people or two different fingers. They are not supposed to match, but if they match, it's a false match. And the rate at which imposter pairs match is called a false match rate, or FMR. Okay, so you have two numbers, FMR and FNMR, false match rate and false non-match rate. And it is basically a trade-off between these two things. Okay, so if, let's say, if you have take these genuine matches and do matching, and these are, let's say, the matching scores. Matching score usually mean higher number means better match. So let's assume that the matching scores are these here, and the imposter pairs, let's say the matching scores are these. Ideally, the imposter pairs should have a lower matching score than the genuine pairs. But it's possible that you keep a particular threshold. This first imposter pair, 44.6, is the matching score for it. It is actually higher than the matching score of, let's say, this yellow to yellow, which is 43.5. So it's usually possible that some of the imposter pairs will end up with a higher matching score than some of the genuine pairs. Ideally, this should be completely separated. All the genuine pairs should have very high matching scores, and all the imposter pairs should have very low matching scores. But there's a trade-off between the two. So if you look at as a distribution, if you take the matching scores and the pair count, if you look at the distribution of genuine and imposter things, your genuine distribution will look like this. That is, it will have, in general, higher matching scores, but it will not be all very high. There will be some distribution for it. Similarly, if I take the imposter pairs and take all the matching scores and take the distribution for that, you will get a imposter distribution. So you have these two distributions, and ideally these two distributions should be completely disjoint, but there is some overlap in this case. And this is the problem. All the errors happen in that overlap region. This is the region where all the errors happen. Okay. Now we also have a threshold. This is the threshold at which we operate. If I'm operating a very secure installation, let's say a military installation, I want to operate at a very high threshold so that only genuine matches should happen. Imposters should not be able to enter the system. So I want the threshold to be as high as possible. The imposter entering the system would happen when some of the imposter pairs will have a matching score higher than the threshold, which means that happens below the red curve to the right hand side of the green line. So the vertical line is the green line, the threshold, and if all the region of the red curve under the red curve to the right of the green would be corresponding to false matches. So FMR comes from there. FNMR comes from the area of the blue curve, which is left of the threshold. Okay, and if I move the threshold left or right, you will see that the area under the red curve increases and the area of the blue curve decreases if I move to the left. Whereas if I move the threshold to the right, area under the red curve would decrease, but the area under the blue curve would increase. Okay, so these are the two errors that we talk about. So false acceptance rate happen on the right hand side here under the curve. The false reject rate or the false non-match rate happens on the under the blue curve on the left. And as you can very clearly see, if I move the threshold to the right or left, when one decreases, the other would increase. Okay, and this is what I call as a trade-off between the two kinds. So I can plot a trade-off curve between the false acceptance rates and the false reject rate or the false non-match rate. FRR is same as FNMR. I can plot a curve between the two by varying the threshold. At a particular threshold, you'll have a single dot. And if I change the threshold here, you will have a different point here on the right hand side now, because now the false acceptance rate has significantly increased. All the red curve is to the right of the threshold, but on the blue curve, there is hardly anything to the left. So which means your false reject rate is very low. Okay, all the people will be accepted in this case, which is also not good. But if I move the threshold, you can see that this will result in a curve which would be a trade-off between these two. Okay, and this is what we call as the different names given to this. There is something called a DET curve and a ROC curve and stuff like that, depending on the context. I don't want to go into details of that, but one of the numbers that people usually report is the equal error rate, where the false acceptance and the false reject rate become equal, and this is what we call as a DET curve. There is also an ROC curve, which is uh, a graph between false acceptance rate and a genuine acceptance rate. So genuine acceptance rate is essentially 1 minus false acceptance rate. Both of them give the same information. In one, the curve is downward, bending downwards. The other is bending upward. But it is essentially the same information between the two curves. Depending on the paper that you read, you might see either a DET curve or an ROC curve. Uh, Nowadays, DET curve is more in fashion. So that's what we do. Sometimes you also do log or semi-log plot of these curves of ROC curve or DET curve can be plotted in semi-log. That way, if you are building a system that is very highly accurate, like 99.9% accurate, the curves become very, very close to the axis. At that point, you will not be able to see the difference between two curves. So you go to the log scale. So in the log scale, the curves would separate out better. So it's very common to see DET curves or ROC curves plotted in the log scale. Okay, and another number that is commonly done mentioned other than EER. EER is useful, but in several other cases, EER may not be very useful because you don't want to operate in the middle. You want to operate in a case where imposters are not allowed. Okay, I want certain guarantee of imposters not being able to get it. So you will say that I want to operate at a FMR of 1 in 100. That's what is called as FMR 100, means an FMR of 1 in 100. That is, only if 100 people attempt, only one person should be able to accidentally get in. Okay, or 99% of the people will be caught if they try to impose as you, imposter as you. So that is FMR 100. If you want FMR 1000, means that only 1 in 1000 should be falsely matched. So at a false match rate of 1 in 100 or 1 in 1000, what is the false non-match rate? Okay, so that is what that is measured by FMR 100 or FMR 1000. And these are very commonly used numbers: FMR 100, FMR 1000, FMR 10,000. Now people even talk about FMR million. Okay, so these are the kind of numbers that we usually report. Okay, you can have the technical definition. Mated pair and non-mated pair are basically these genuine and imposter matches, and whether the system matches or not is given at the top, and then this 2 by 2 table will tell you what the true matches, what the true non-matches, false match and false non-match. So these four numbers, this 2 by 2 matrix, will actually tell you the complete story. This is about one-to-one match. Now, what happens when you go to this usually the story of false match, false non-match all works for one-to-one matching. What happens if I go to one-to-n matching? Think about it. What happens to first false non-match? Okay, it's very fascinating to think about it. If I take my right finger impression once and I take my right finger impression again a second time, maybe the next day, and they are supposed to match. If they don't match, this is a false non-match. It does not match and it's falsely don't match. So it's a FNM. Okay. Now the question is, if my system has got 1% or 10% or 1000% or a million or a billion percent, this error rate doesn't change. If my finger does not match with my finger, it doesn't match. It doesn't, I don't care whether mine matches with somebody else's or not. Only when I talk about my finger matching against somebody else's, the scale becomes an issue. The number of people become an issue. If I'm talking about my finger against my finger, it is just one match whether it happens or not. So false non-match rate is independent of the database size. Okay, so in the case of larger systems, if false non-match is called false negative identification. False negative ID means your finger does not match with yours, and that is FNIR. That is not such a big issue. That doesn't change much with scale. But the FPIR, think about it. If my finger accidentally matches with another person, let's say 1 in 100, what does that mean? That means that if I put my finger and I match it against 100 people, one of them will accidentally match. Mine who should match against mine, yes. But in addition to mine, there will be another person who will be accidentally matched because you have an error rate of 1%. So even in a classroom, attendance system, if you have a FPIR of 1 in 100, sorry, false match rate of 1 in 100, that means that every person will accidentally match against, on an average, every person will accidentally match against somebody else. Okay. So FPIR tries to capture this idea. So FPIR of the false match rate of 1 in 100 will result in a FPIR of 100% if the database size is 100. If I have a false match rate of 1 in 1,000, and if the database size is 1,000, then you have an FPIR of 100% again. Okay. So FPIR depends on your database size. That is, if I match my fingerprint against all the people in the system, how likely, what is the percentage of, or what is the fraction of times when it would accidentally match against at least one person with other than you. Okay. That is the false positive identification rate. So if it is 1,000 person database, then you know you can do. I mean, so let's say a database of FPIR of 1 in 1,000. What would be the false match rate is the question. So actually, it should be called FMR of 1 in 1,000. What should be the FPIR? So you would have what is the FMR required? I have put it the other way. You want an FPIR of 1 in 1,000 in this case. That is, if I match my fingerprint against the complete database, I don't want error rates more than, let's say, 0.1%, 1 in 1,000. If that is the case, then what should be the false match rate? If the database is 100 sized, and if you want 1 in 1,000 false positive identification rate, your false match rate should be the product of these two. So 1 in 1 lakh, that is 0.001%. But if your database size becomes larger, 10,000, then you require 10 to the power minus 5 percentage. That is 10 to the power minus 7. Okay, percentage means 1 in 100 also. So keep that in mind. 1 in million, 10 to the power minus 7. 1 million database, 10 million database, 10 to the power minus 8. 1 billion database, 10 to the power minus 10. So in the Aadhaar scale database, we are talking about a system which does a false match at a rate of 10 to the power minus 10 percentage. That is 1 in 10 to the power minus 12 should be the false match rate. You should have an accuracy of something like 99.99999%. Okay. Extremely accurate in terms of false matches. Very rarely should there be a false match. And at this rate, you want to have a reasonable false non-match rate. That is, false non-match means that you try to put your fingerprint on the system and it recognizes you. Okay. So this is the issue. Extremely high accuracy is required. It's a unbelievably high accurate. Most of the systems that we talk about in research never reaches this level of accuracy. But if it does not operate at this level of accuracy, it becomes useless. Okay. And FNIR, the other part of the story, at this FPIR rate, FNIR determines the uniqueness. That is, if you put your finger and if it does not match against you, you can get multiple Aadhaar numbers. So you don't want to have that also to happen. So that we need to reduce it to something like, let's say, 1 in 1,000. So you need to have a 1 in 1,000 FNIR at an FPIR of 1 in 1,000. And an FPIR of 1 in 1,000 in a database of 1 billion means 10 to the power minus 10 percentage of FMR. So this is the high level story. So I hope this part is, the difficulty level of accuracy is clear to you. Any question here? Okay, good. I'm assuming that what I'm saying is coming through. So let's move forward if you don't have any questions. Uh, a few other points I want to bring up, and then I'll quickly talk about some of the design decisions that are done in creating that a system, such a system. So we have to wrap up in another 5 to 10 minutes. If you have any questions, I would like to go for another 5 minutes and then open up for any other questions that you have or any other discussions that you have. So I'll quickly go through some of the other challenges and then uh, get to this. So before going forward, how do we achieve this kind of accuracy? Of course, with a single finger, you will never be able to do this. Okay, or a single iris, you will not be able to do this. So we need to combine multiple things. So if you have 10 fingers and two iris and a face, by combining all these things together, you might be able to achieve this kind of accuracy. Okay, because when you multiply two systems, if you say that system, the first finger has to match and the second finger has to match and the third finger has to match and the fourth finger has to match, then your false match rate suddenly comes down. Okay, so you actually make use of such systems. So if each finger has got 99% accuracy, when you multiply them, you can actually improve the FPAR significantly. So think about that. That's the advantage of using multiple biometrics, and that's the reason why multiple biometrics are taken for Aadhaar. It's not that you require all 10 fingers for your authentication. Every time you want to do an Aadhaar authentication, you don't need all 10 fingers. But the deduplication part, when you try to match one against a billion, this is okay. Image quality is very important. Fingerprints usually of you know the younger age tends to be good, but as the age progresses, your fingers become more uh, cut, bruised, dried up, and that will actually have poor quality fingers. Iris also can get good or bad quality based on the blur of the camera. If your eyes are moving, your pupils are dilated, all these things can create uh, poor quality iris. So it also depends on the hardware. That some of the devices, these are some of the devices that have been tried out, have got higher quality acquisitions as compared to others, but then the cost is also a factor. So you have to declare, or you have to create a minimum quality. So there was uh, an agency created under I forgot which one. I think it is NIC, National Informatics Center. Under NIC, there was a system, a committee or a agency created which would actually certify these devices to be used for Aadhaar. They would check all the quality and make sure that this is sufficient quality before it is approved for use in Aadhaar. So that was one of the side activity that had to be created for this purpose. Matching speed, as I said, if you do a very quick uh, back of the envelope calculation, if one finger to one finger match takes uh, a millisecond to match, okay, not even one finger, I think it's 10 finger to 10 finger, this thing happens. Uh, what happens is that I need to match one against a billion, okay, and that if you take a single enrollment, that is one match against a billion, would now take about 300 hours, because one millisecond means a thousandth of a second. So uh, a thousand matching against a thousand would take 1 second, and 3,600 seconds is an hour. So if I have a million, 3 million people, that will take an hour, and a billion would mean 300 hours. So it's really, really important to be able to match. This is the time to match all your 10 fingers, two iris and face against another set of 10 fingers, two iris and face. If that takes 1 millisecond, then for enrolling a single person will take about 300 hours. And if I put a system with about 1,000 processors, if I want to enroll every Indian, it will take about 20,000 years. So you can imagine what kind of system is required if I want to enroll every Indian. The speed at which you need to operate is extremely high. So all 10 fingers, two iris, face, all together, if I want to match, it should take much lower than a millisecond. So extremely fast speed required and extremely high accuracy required. It's like a very difficult case to solve. Okay. So people try to ask why not use some kind of indexing system. Like Henry had proposed a system of classification for classifying fingerprints into 6 classes and see if I only match against those classes, can I improve the speed? Indexing is a very common system used in databases to improve the speed of matching. Why can't we use it? the the problem is that if any error that is made in the indexing stage will completely transfer to the total error rate, and that is usually not acceptable. Okay. uh, People have created systems that can do matching much faster than uh, 1 millisecond match. What I mean, 1 millisecond means 1,000 matches per second, and people have created systems that can match at 1 million per second, or even iris has been done at 300 millions per second, so at very high accuracies. So it's, we need to ensure that whatever system that we design, our machine learning system, is extremely fast to match. I'll skip this part. Okay. So first requirement, system design, if you put all these things together, your ID should be unique, means your first negative identification should be 0, but 0 is never achievable. It is, but you aim for something like 0.1% or something like that. You cannot reject anyone. As I said, this is BFTE, is biometric failure to enroll. So as we said, even if your fingers are missing, you cannot reject them. Actually, it happens in about 0.1, 0.2% of the cases, one in 1,000, or two in 1,000 kind of numbers. There is a biometric failure to enroll. Their fingerprints are too worn out, or too dry, or fingers missing, or cataract or some blindness would have removed their iris, and so on. So there are several reasons why biometric failure to enroll can happen, and it happens more often than you think, and you need to use several other mechanisms to counter that. So the system has built that into it. Especially children and seniors are one of the issues. No documents should be mandatory. If you want everybody to be enrolled, you cannot insist that everybody has documents. Many of the people in India don't have any documents to prove their name, age, gender, or anything. uh, we also had to create a system where enrollment has to happen through other agencies. Aadhaar by themselves cannot do enrollment because of political issues. So how do we control for data quality when you are not actually enrolling, somebody else is enrolling? So you have to create enrollment stations and then standardize that and make it available to other enrollment agencies, so that when they do enrollment, the quality is maintained. Okay. So, and security, privacy is maintained. So anytime you do acquisition, immediately after acquisition, the data is encrypted with a key for which the decryption key is only available in Aadhaar. So even when they capture, it is immediately encrypted, and after that, nobody can read it until the data is sent to Aadhaar. It reaches the database, and inside the database there is the decryption key, and that's the only place where it exists. So those kind of security mechanisms were put in place. One should be able to enroll without being online. So it was, as I said, the data was transferred through USB hard disks or pen drives. And we should also be able to handle things like 1 million enrollments a day. So one of the decisions that were made was that we will not use any proprietary hardware. We will use only generic hardware, like standard servers with Intel or AMD processors and stuff like that. No specialized hardware allowed. And also the response should reach back to the every enrollee. So Indian postal system was co-opted to deliver this thing back. So the whole system was created to cater to the realities on the ground. That was the most important part. And several practical challenges like cost and quality were talked about. As I said, the standardization of devices through this agency under NIC was taken care. Certification was done. To scaling and the capture, the data had to be done by other agencies. Encryption at source. How to control for quality. The software was developed which will automatically detect quality and ask for recapture. And also, one of the interesting things that was done is scaling and migration should be enabled, and which means proprietary templates should not be used. The raw data has to be to be used, and vendor lock-in has to be avoided. That means if I'm using one particular company like NEC or L1, some company is being used, It should not be that if they go out, our system will stop to function. So there were some interesting design decisions that were made which would take care of that. So I would talk about that. We also already talked about privacy and function creep. Okay, so I'll skip to what the last two parts, which is how to take care of this uh, privacy and function creep, and then we will uh, stop at that point. Just a moment. Let me. I'll skip through this one. Some of the parts I'll skip. I'll just get to the scaling and mitigation part. So one of the interesting design decisions that was made is that this one-to-one matching is not going to be done by one company. It's the first system in the world which designed it in this way. So we said we'll have three different companies running, and they'll be running in parallel. So this ABIS is automatic biometric identification system, the one-to-one matcher system. There are three different companies which are running in parallel, and the system was set up in such a way that all three will do the deduplication in parallel, and any person who comes in can be sent to any one of these modules. So what happens is that since all three are running in parallel and they are also made to compete against each other, whoever gets better accuracy, they will get more job and they'll get more money. So they are always competing against each other to improve their system. And even if one of the systems goes out of service because of either the company goes bankrupt or some political reasons, somebody goes out of the system, the other two are still there and they would continue functioning, which means all the functionality would still be available through the other two systems. And you can bring in another third person at that point, which will become the backup, or running in parallel again. So this design was chosen very judiciously so that other factors does not affect our system. Okay. Then one more point I wanted to make. So this is some part of the work that we did. So one of the work that we did for Aadhaar, which is now being commissioned, is that if you go back to just, I'm sorry, let me go back to this system. So one of the work that we did is that because there are only three companies now, and in fact, all three companies are actually non-Indian. So one of the things that we wanted to do was to develop an indigenous ABIS solution. So as a research group, we were tasked with creating the biometric part of that design. And I'll just tell you what are the primary components of it, what we have done about it, and then we will start. Okay, so for each of the biometric modalities, first you need some kind of segmentation system where if you have all the 10 fingers, you need to be able to correctly segment each of the 10 fingers. And remember, any of these system has to be extremely accurate. The problem with developing such a system is the accuracy issue. Like your accuracy, unless it is 99.99%, you still have this problem, because any accuracy at any of these stages will cascade, and errors will cascade and add to your very, very high accuracy requirement. So first stage should be the segmentation of the 10 fingers. And if iris, you need to segment out the iris part. Face, of course, is the face detection part. And then there has to be some quality metric which will tell you whether the data of the quality is acceptable or not. If it is not, what to do with it. Can you do some kind of enhancement? That could be a possibility. Next thing is do some kind of spoof detection or presentation attack detection. What if they are they presenting a real fingerprint or a fake fingerprint, or a fake printed face? If they show in front of the camera, can you detect that? So this is what is called spoof detection or PAD, presentation attack detection. So you need a module to do that. Then if the quality is bad, you need to do some kind of enhancement. And then the main part comes in, which is templating. That is, can you take the fingerprint, face, and iris and convert it into a feature vector that can then be used for matching? And this is the most critical part. If you do this well, if your template is good, then it would take care of most of the issues at that point. Okay. And this is where all the research has gone into how to create a template which is extremely high quality in such a way that it can distinguish between, get these accuracies of 99.99% and so on and so forth. Okay. And the second design decision that we made is that since the matching has to be extremely accurate, we will simplify that process. We said that the matching would be done with a very fast comparison algorithm. So you can use very complex comparison algorithms, or you can use very simple comparison algorithms. We decided we are going to go with something very simple, like either Euclidean distance or cosine distance or Hamming distance and stuff like that, and then try to design for it. So you need to go from the requirements back to design this, and then combining all this, we created a template which is about 3, 4, 5, 6 in size, and that is used to currently match in the system. This is designed, it has been implemented, now it is being piloted inside Aadhaar for smaller scale deduplications. Now hopefully it would reach a full scale deduplication of that. Okay. uh, since we are running out of time, I'm not going to talk too much about the research problems that we work on, but I hope I have given you a quick idea of what kind of challenges are in building such a system. There are several open systems that open problems related to this that are still pending. Uh, some of the issues are related to verification with age difference. Your first enrollment is when you are very young, and then you are later captured at a much later date. How do you match between these phases, which is from young, very young age to older age? Dealing with infant and child biometrics is another problem. Robust and inexpensive sensors has to be created if you want to make it far more accessible. Interesting problem would be if you can use mobile phone as a sensor. What are the challenges in that? Unsupervised authentication, like I talked about, presentation attack detection, fraud detection, and so on. A lot of machine learning uh, techniques can be used in these cases. Automatic template update, as you keep on using the system, can you update the template, and how do you make sure that the automatic update does not introduce more errors in it? And you can also think about interesting applications that can be built on top of such a large scale authentication system. So that's all what I wanted to talk about. I think I've run over time. If you have any questions, I would be happy to answer.
Thank you, sir. It was a wonderful session. There are some questions in the chat box.
Yeah, I'll go over that. Just give me a second. Is the template size in terms of number of bits? Okay, this particular one is number of bytes. Actually, these are number of numbers. So 512 numbers for each of the templates. The length was what I presented. So each number can be represented as a 2 byte. What was the other question? Sometimes in face recognition, it gives wrong image also as authenticated image. That is what is we refer to as a false match. So yes, it is possible to get a false match, and for authentication, none of the system is 100% accurate. So we need to reduce the error rate to such a low level that we are able to deal with those errors. So what happens in the case of Aadhaar? All the numbers were designed. So I was primarily talking about the deduplication part of Aadhaar, that is the 1 to n match of the Aadhaar. If you're talking about the authentication stage, that is 1-to-1 match, that is still an issue. We can discuss that separately. But the 1-to-n match is where I focused on most of my effort in. And what happens is that the bigger issue is when you get a false match. That is, I try to enroll for Aadhaar by giving my all 10 fingers, face, and iris. It accidentally matches with somebody else's, and it says that, sorry, you are already enrolled in the system. You cannot be given an Aadhaar number. That is not acceptable. So what happens is that whenever that happens, whenever there is a flag that is raised saying that this person is already enrolled, it always goes for a manual verification. So it never rejects a person without a manual expert looking at the system and saying that, yes, this is actually a re-enrollment. It is not accidentally matched. So several other factors like their demographic details, their name, address, all those other things are taken, and the photographs and fingerprint are presented to an expert. They will look at it and take a final call. So the final rejection never happens from the system. It happens from a person, and that make sure that several of these cases are taken care. Next question: what kind of algorithms are generally used in Aadhaar? Are deep learning algorithms used or other neural networks used? Yes and no. Deep networks are used uh, in the current systems. The original systems that were in there, uh, they were mostly not based on deep learning. Because if you remember, the first set of systems were installed inside Aadhaar in 2010, and those were developed by people over several decades. So these things started far before deep learning came along. So it is the primary systems were not deep learning based. They were based on traditional image processing and pattern recognition and so on. Uh, but over a period of time, people have been updating their systems, and now deep learning based solutions have also come into matching. In addition to that, Aadhaar has created their own solutions. Some of them we have worked on and given to Aadhaar, which they have then further fine tuned on their data. We don't get the data from Aadhaar, so we develop deep learning based solutions and then pass it on to Aadhaar, and they would do finer fine tuning on their data and then deploy it. So things like spoof detection and you know even face match, which has recently been used for face authentication. These are all based on deep learning based solutions. So yes, deep learning based solutions are used, and it is becoming more and more deep learning based solutions. Now, one interesting thing is that for three of the fundamental problems like fingerprint, face, and iris based matching, one to one matching, they are going to run a competition. So we are actually jointly running the competition. We are in the final stages of building that portal, which will be opened sometime in January or February. You can submit your fingerprint or face algorithms or iris matching algorithms, whether deep learning based or otherwise, and that would be run against some of the uh, data inside the Aadhaar, and the result would be published as a leaderboard. So you can try running your algorithms against Aadhaar data, and it will rate them. There's even a prize money of reasonably a good number. I'm not going to tell the number right now. That will come out later. And uh, if your system is really good, then they will also be interested in purchasing it from you. So it's also possible to strike a deal at that point. So there's several advantages to that. So watch out for that. Look at Aadhaar's website. Sometime either January or February, this will open up, and it should be open for a few months. If you can build fingerprint matching algorithms or face matching algorithms or iris matching algorithms, and the system would primarily be for age difference. So the one of the faces would be from 5 to 10 year old, and the second would be around 15 or 20-year old uh, face. So for the same person, about 5 year difference uh, between the two, 5 to 10 year difference between the two. And can you develop a face matcher and a fingerprint matcher which would do that kind of matching? Okay. uh, so it's getting late. So that is something that is coming up, so please watch out for that. If you're interested, you can participate in it. Can you kindly share the presentation? I'll send it out later. Okay. uh, there's one more question. Did your group work on transfer learning to Indian data or training from scratch on Indian data? So it's most open source data. Okay, good question. Did you use VITs or CNNs? Tried both. We started with CNNs, but we also tried with VITs, and VAT seems to show slightly higher accuracy on our data. So we have collected our own Indian data within the lab, and in that, VATs showed slightly higher performance for the same amount of compute budget. But these were then fine-tuned on Aadhaar data internally. So that we don't get it back. We take it to there. We run the training inside Aadhaar's servers, and that those are the ones that are being used right now. So that data cannot come out from there. So it's primarily going in. So the what is the order of data that has been collected? It's we had something of the order of uh, you know couple of tens of thousands of people that we did on part of some of the earlier projects, which were used for the fine tuning and testing within the lab, and then that was sent out. But those are very small numbers with respect to what the kind of accuracy that is required. You will not be able to achieve that kind of accuracy with these 10,000 is very small for that purpose. So it had to be trained on Aadhaar data, which is of the order of 1 million uh, identities, which was used for the to achieve the kind of accuracies that we talked about. Okay. So that happens inside the Aadhaar center, in the Aadhaar, their own servers, and the training happens there and just being used. Okay. I think we're running out of time. So thank you. Thanks for your interaction.
Hello, Dr.
Hello, sir.
Nambudri.
Still
We
we
have
have 5 minutes.
one quick question.
Sure, please.
So, do we have any published literature, especially in terms of the matching algorithms that are used? No, is it confidential?
Not confidential. We have been trying very hard for Aadhaar to agree to publish this one. We are trying that. We would like to publish it. We will hopefully they will. The that bureaucracy has to agree somehow. So once that goes through, we will hopefully publish that.
I'm just curious to know, like in a very high level, in that one-to-one matching, were you using any locality sensitive hashing or any Bloom filter or anything?
No, we any such thing. The problem is that the any error rate that you make cascades. So, this is again the difference between a research problem and a practical problem. If your accuracy requirements are extremely large, then what we're doing is just get to a representation which is very good, so that you just do one-to-one brute force matching after that.
But that would take a lot of time, right? For the
So
matching.
how to make each match as fast as possible, and then span it over hundreds of cores, and
Okay, you are achieving through parallel processing.
parallel processing. Yes.
Okay. Another quick question is,
But we have something like finally thing is running around 10 servers, each one having 20-30 cores. The standard servers which have like 30 cores or 40 cores are there, and such 10 servers. So you're talking about a few hundred cores parallelized across that.
that's